right, greetings everyone, and welcome to another exciting episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, we are continuing on with our Python programming series. Joining us back in the studio again today to lend his expertise on the very topic is our good friend and mentor, Mr. Justin Dennison. Justin, welcome back to the show, sir.
Thank you, Daniel. And today we're starting off with a little more iteration, and we're really going to dive deep into strings. So strings are we've been using them, we've been testing for them. I've said, hey, it's just some characters, it looks like a sentence, but it's very important to realize some neat properties about strings, because if I'm running through and trying to look through error logs, or if I'm trying to look for information on a computer system, trying to track down problems, or maybe just doing like a frequency analysis. If I was a computational linguist, then I could do frequency analysis based on character counts, which, side note, is an interesting way of breaking certain ciphers. Frequency analysis for Caesar ciphers, gone, over.
Totally obliterated.
Just horrible. So that was an interesting but yet awkward aside, but let's go ahead and get started on some strings. So I'm gonna actually hop into the terminal and let's just review what strings are. And there's some methods that we haven't used, even though we've been using strings. So I'm just going to define my string, and again, in quotes. I can use double quotes or single quotes, and this may be a sentence like, here we are recording, and I have to open and close the quotes accordingly. But now here's where it comes to the horrible, weird hiccups that people will have. A string is a collection of characters. For instance, if I ask you to spell your name, how would you do so?
I would use the American alphabets, or the English alphabet, should I say, of D, A, N, I, E, and L, and put them all together in a formulated grouping so that it wouldn't get confused with any other letters that might be on a page if I was writing this. And that would be it. I would spell it out using those characters.
And it seems really intuitive, because when you ask someone, hey, how do you spell that? They name off character after character after character, which effectively how strings are treated in Python and some other programming languages. It is a collection of characters put together in very particular ways. I think what really trips people up is space is its own character, new line is its own character. So you can have a space and a new line and they count. And uppercase and lowercase are not the same. So there's multiple ways of encoding these. You have ASCII tables, UTF-8. Those are behind the scenes, but sometimes you will run into problems. I don't foresee most anybody running into problems with these. But because these are collections, this is a great way to introduce some more of these complex features that people have trouble with. Iteration is one, and we're going to use iteration, but also accessing these elements and moving these things around and trying to count how things work. So let's look at a couple of methods within strings and then actually use them. And what I mean by methods are functions that operate on a particular data type. So these are for strings only. They operate a particular way on strings. You may see these methods used with other data, but they'll do something a little bit differently. Now, I'm also going to introduce a function to really help us. Sometimes in the interpreter, I want to know, hey, what are some things I can do? So what can I do with strings? If I type dir as a function and give it the data type, which I can get from type, it'll tell me all of these things. These double dunder stuff, for now, I would not worry about those. But when you get down here to capitalize, center, count, decode, these are all methods that you can use with strings, and then there's some other ones that have special syntax.
Justin, would you say these are manipulators maybe even?
So that's an interesting question. Strings are immutable, and I'm glad you brought this up. And what do I mean by immutable? If I say, my string, I can't change the value of whatever's attached to that. So here we are recording, right? None of these methods that are listed here change that string. They will give you a copy of a new string that has the changes for you. So behind the scenes, I can't actually change, and we'll see that that actually brings up an error if I try to do that. But it's something to keep in mind. Strings are immutable, which is not, with everything we've done, I can change stuff, I can do whatever. Now that does not mean that I cannot reassign a variable. So variable assignment is different than actually changing the data. So we'll take a look at that. Excuse me. But the first thing with a string, like my string, is I want to know, right? My first name has 6 letters. People are like, oh yeah, so that's even cool. I can actually use len as a function and say my string. And what was that string again? Here we are recording. So there's 1, 2, 3, 4, 5, spaces count, 6, 7, 8, 9, 10, 11, blah, 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 onward and upward. So the length of my string is 21 characters. Great. We can also do things like, I just want the first letter of my string. I want the very first one, and it returns an H. Daniel, do you see something kind of odd about this?
Yeah, you use the 0 number instead of the first, right? Because first would be 1. So I don't understand, why would you want to use 0 instead of 1?
And this is a giant hiccup for a bunch of people. Collections in Python and various other programming languages typically start what are called zero-based indexes. We start counting with 0, which is really weird because I don't go, there's 0 cups, there's 1 cup. It's not something that's intuitive, but it makes like memory management and some CPU stuff a little easier to manipulate if we start at 0. So if I start at 0, then the second letter is actually indexed at 1. And if I wanted to say all the way up to, and notice the length here was 21, I wanted to go to 20, that actually gives me the last letter. So the maximum index is 1 less because we've taken all these numbers and shifted them back 1. So we have to be careful, because what if I wanted to access 21? I actually get an index out of range error.
So the problem is the inherent way that the computer actually counts. Most computers start counting with 0, and that is something that can, like you said, can definitely trip us up because we're so used to counting starting with the number 1. I've actually done this. I ran into this as a problem in Bash scripting, actually. I was setting parameters on the end of a command. So I created a script. Script has a name. I want to execute that script. I can add parameters to the end of it. But if I started counting with 1, the problem arose and it wasn't working correctly. I had to remember I got to start counting with 0 because that's the way computers count. Apparently we're running into that same problem. I say problem, it's just the nature of the computer. It's the same here.
Yeah, exactly. I mean, this is a pretty pervasive practice with computing. I know there are some languages that start at 1 to make them more intuitive. For me, if you've ever done any programming or you try to read other people's code, it's necessary to understand how zero-based indexing works for collections, because you'll see that a great deal. So Python decided not to do that. But along with these collections, Python, Guido van Rossum decided to introduce, in addition to this syntax, another thing called a slice. So usually when I wanted to grab the first to the 5th letter of something, I had to write a for loop, grab all of these things, build a new string, return it. But let's say I want the first, which is 0 indexed, to the 5th, which is 4 indexed. This is just like the range function. It doesn't include the index of 5, but the 5th letter is actually indexed at 0. And we'll take a look at that. So if I want to go from 0 to 5, I get the first 5 letters, and 0, 1, 2, 3, 4, but there are in fact 5 characters there. The space counts, which is handy because if I want to start pulling these things apart, like if I'm doing like text-based processing, which is, big data is all the rage. That's definitely something you do in big data, is processing text and information. This is way handier than anything I've done in other languages. In addition to, let's say that I want to go to the very end. So I want to go from 0 to the end, but I don't really know. I could do something like give me the length and do all kinds of math. But if I actually don't give it a parameter, it'll just assume that I want the whole all the way to the end. So that's handy. Slicing is very handy. And just like the range function, we didn't see this, but the range function allows us to do what's called a step. I can go from 0 to the end by 2s, so I can get every other letter. And you'll see that's kind of, I have not changed.
It's like Old English.
Yeah. And Chaucer.
Yes. I'm going to read Beowulf today.
I have not changed my string. I have gotten a copy of a new string with the changes that I requested. So that's something to keep in mind. With that immutability, we may think we're making changes, but if we try to make a change to my string directly, right, if I wanted to change the first letter to 3, and I'm like, okay, I'm just going to assign a variable, or let's actually make it a string so you're not like, well, you messed up. String object does not support item assignment, so it does not allow me to do that. So I've got length. I know how to do what are called slices, but I'm going to pop back over to this string thing and highlight a couple of very, nice functions to have. For instance, is lower, right? It'll tell you if it's lowercase. I wonder what capitalize does. So I don't know. So I want my string dot capitalize spelled correctly. Has no attribute capitalized. Did I spell it incorrectly? And I did.
Yes, you did.
I sure did. There's your problem. Capitalize, that'll actually, so just to show you, my string 2, hello, and then if I say my string 2 dot capitalize, you got to watch me, Daniel. I don't know.
That's right.
It'll actually do normal capitalization schema, first letter capitalization.
Oh, that's very cool. That's a nice little function there to throw that in to be able to say, you know what, maybe I forgot and I need to have all these things capitalized. I can just go through there and add that to it, and it will change it for me.
Right. Yep. Wonderful functions. I definitely I use this stir. I'm like, I wonder if there's this thing. Oh yeah, I can do this. Oh yeah, I can do this. There's some other functions that we'll talk about in just a moment. But I wanted to illustrate, this is calling a function a little differently than we have in the past. I'm using the dot operator because I want to take this string, my string 2, whatever value is in there, and then capitalize that thing, right? So I'm calling this function on this thing. They're called objects in programming. But anything listed by, this dir is going to be called very much in that way. So if I wanted to count, and this is what it doesn't tell you, count it takes a parameter. I would have to go look this up, but if I do my string 2 dot count L, it counts how many times that character occurs within that string. If I do my string without the 2, 0 times.
Wow, that's
So
really cool.
yeah, I mean it's easy, intuitive, because I go, okay, I'm counting the number of L's in string, and it gives me a number. And we saw a couple of other, like when I say hello times 3, I get that back 3 times. So that's the repetition, repeat operator. I can also push through 2 strings together if they are strings. Now we saw, if I do this, then I get an error. It's like, hey, you can't put these 2 things together. But if I type correctly, if I actually keep two strings, then the plus sign takes on a whole new meaning. I can actually take these two strings and squish them together. And I can do that for as many strings as I want. But that leads to an interesting, thought process. I can actually build strings, right, from I need every other word in a sentence and then return a new sentence. It's kind of weird that I would do that, but maybe that's what I wanted to do. And then finally, if I wanted to really format, if I know what the general pattern, and this is where paths come in, URLs, file names, if I know these follow a pattern, Python has a lot of ways of creating like a general format for strings, but personally, I like this format operator, and it would take as many arguments as there are sets of curly braces. So this, I told you, Python was not great about curly braces. They got rid of them, but they are good for formatting. So if I know that I want a space between two words, I can say hello, comma, world, and then I'll actually build that string using that pattern and the inputs in order.
Yeah.
So strings are very powerful and come up a great deal whenever we're doing text-based processing, which I actually do, or looking on the internet, or cron job automation, write a script, look through all these, hey, this is a log, send me an email. So very, very powerful.
Now, Justin, obviously you've given us some good power, or at least some expansive capabilities to working with these strings. Now that we have these abilities, what can we do with them? What's the practical side of working this way?
So what would we do with them? That's a great question. I think it's best to maybe just make a program. Let's see a couple of things in action instead of hanging out in the terminal. I've set up here, and I'm just going to make my string as a variable, and I'm just going to lean on the keyboard just like that. See that right there?
Yeah, that's lovely.
Yeah, it's handy. So you can imagine this is a giant log file. Are you going to go through and count every time error occurs in there?
Negative.
No, I'm not, right? I could use count, right? So we could just say, hey, print my string dot count, and what is it? Let's just say how many times does df occur, right? It has to look just like that. Let's go run it. And that only occurs one time in there. So that's incredibly powerful.
Yeah, it was
right?
it was much faster than us going, okay, let's see here, ASD. No, you went to L there, okay. And working our way, that's a very long string. It would take us forever to do that. And that's just an example, right? There's much larger strings of text. Log files is a great example where I'm looking for a specific string in general, and I don't want to parse through that. I want to let the computer do it. It's a whole lot faster than I am, and obviously that's the way to go.
Yep. And let's just see, to confirm our suspicions that this is looking for DF as that pattern. I know there's a bunch of D's in there because I was just on the home row going, I like playing on my keyboard, doo-doo-doo. And there's 17 D's in there. Now, I just leaned on the keyboard, but you can think, I've seen log files in the gigabytes, and gigabytes of text. There's lots of text in there. I can now go, how many times did errors occur on these daily files? That's great. But now, I've noticed, what if I wanted to count how many times a letter for each letter occurred, right? A, B, C, D, E, F, G. I just got tired, right? But now this lends us back, oh, this is iteration. All right.
And repetitive tasks.
Yeah, repetitive task. So I could say this. How about lookup string, and I want to look for each individual character, A, B, C, D, E, right?
Mm-hmm.
Okay. And this is where strings as a collection really shine. I can say, okay, I'm going to look for in the lookup string, I'm going to start at the first one, and I'm going to look for how many times that occurs in my string. Just like maybe this is error, right? Or debug or log or something that would happen in these files. I can actually say, since this is a collection, for char in lookup string, print char, print my string dot count char. So I have abstracted away and made this very, very short. Okay, I'm going to start here. I'm going to look at A. So char is going to be A the first time through, and it's going to count how many times A occurs. And it's just going to print those out. Now I put this char in here so we can see A, number, or A, B, C, D. Let's actually go look at what that does. So A occurs 9 times, B occurs 14, C is 10, D is 17, E is 1. All right.
Sweet.
Yeah, that's fast. And that was easy. As I said, strings offer us a great deal of power, but because they're a collection, I can use iteration with them. So what, I wonder what would happen if, let's see, there's one other thing that we can do with strings. I'm going to write the exact same for loop, and I'm going to result, okay, equals, it is the char plus colon space plus, and now I have this new operator, this new function that I can try to force something to behave like a string. So just like I had int, I can force behavior like a string. I can say my string dot count and just count the char. So I've nested these. This is sometimes hard to read, but what this does is say, hey, figure out this number and then pass it back to print. Here, figure out this number, pass it back to string, which will then turn it into a string, and then do the plus sign. And as we saw, the plus sign, it just squishes them together. So now I can properly format my output. And let's see what that looks like comparatively. And I didn't print anything, so that's not going to work. So let's print the result. And notice now this output is nicer.
Yeah, very nicely formatted, actually.
Yeah. Now, what's amazing is when we get to reading files is I can actually make like CSVs, TSVs, and then they'll open directly in my Excel spreadsheet editor. So amazing, amazing stuff. But, I think we saw something that actually make this easier than we have it right now. Are you ready, Dan?
I blow my mind.
About to blow your
Let
mind.
me put my helmet on.
Yeah, be careful, be careful. So again, notice that I'm indenting appropriately. I have an indentation here, an indentation here. And so let's say for char, one more time. I know you're like, okay, you're doing the same thing.
Repetition breeds retention.
Yeah. But I'm now going to use that formatting so I can go, okay, I know exactly what it's going to look like. This is going to be my character. This is going to be my count. And I'm going to format it with like character there and count there. Not the greatest format, but
Gets the point across.
this is a little more complex than what we have up here, and this gets messy fast. So when I can just go, okay, here's the general pattern that I want, and then I can say format. In the first one, I want the character, and in the next one, I want my string dot count the character, and then print result. Character A has a count of 9. Character B has a count of 14. So, strings are very much iterables. You can iterate over them, and they they make things easy when we know how to manipulate them.
Yeah, obviously it makes it a whole lot easier, especially for the end user's experience. Which you got to remember, that's kind of what we're doing this for. Even if that end user is ourself, you want to put in the best type of formatting as possible, and being able to manipulate the strings as we have using these different manipulators is going to be very, very helpful in that task. We want to have that output give us a little more information. As we saw, it was very ugly, even though functional in our first for loop that we created to do the count of the characters. And as we moved our way through it and gained a little more power, a little more knowledge that Justin gave us there, it started to get prettier, it started becoming more readable, it started becoming more useful to us or whoever as the end user. Justin, is there anything else that we can do with strings that you would like to explain to us for this episode?
Well, there is a great deal that we can do with strings, but we need a few more tools in our tool bag. We have a good foundation, but we need a couple other things before we can really harness their full power.
That's right. Not too much too soon, right? I don't want you guys drinking from a fire hose. Well, thank you so much, Justin, for explaining strings to us, at least the expanded capabilities that are there lying underneath the hood of Python. Obviously, it's a very powerful tool, and to be able to use iteration through them, that is also a very powerful tool. Put those two together, you got some serious horsepower. That being said, again, thank you for joining us. Thank you guys for watching out there. Hopefully you've learned something and you got a lot out of it and you enjoyed it. On top of that, we're going to go ahead and sign off for IT Pro TV. I've been your host, Daniel Lowry.
And I'm Justin Dennison.
And we'll see you next time.